Hello and welcome everyone. This is a brand new episode of OpenInfra Live. I hope you are all having a great day. Well, as for myself, I'm still waking up, sipping on my mango flavored coffee. And yes, you heard me right. I said mango and coffee together in a really short sentence, and it's actually amazing. But this is not the only interesting thing that you will learn today. My name is Ildiko Vancha. I will be your host for today's episode. And despite of all my efforts, the best angle still had the light on top of my head, so I feel like I'm your angel for this episode. So I will do my best to act that way. Before we jump into today's content, I would like to just welcome those of you who are new to the show. OpenInfra Live is an interactive series that is brought to you by the Open Infrastructure Foundation. We are coming to you every Thursday at 1400 UTC, mark your calendars, live. And we are bringing you production case studies, open source demos, conversations with industry experts, and just updates from the global open infrastructure community. I mentioned that this is an interactive show, which means that it is very important that we have you to participate if you're watching us live. So please use the chat of the platform and tool that you chose to follow us on today and type in your questions, comments, so we can have you on the show as well. And if this would not be enough for you and you like to have the spotlight, then please collect your ideas and submit your story to ideas.openinfra.dev so we can have you on for one of our upcoming shows. And now that I got the housekeeping items out of the way, I have to tell you that I'm really excited for today's episode. I myself started to contribute to OpenStack 8 years ago. This number is getting so high, I can't believe. But this is such an amazing and welcoming community that this 8 years just felt like 8 days. I'm so happy to be part of this community that I've been also participating in a lot of onboarding activities. We have an upstream training that I will be talking about just a little bit towards the end of this episode. And whenever I do the intro, I always start with reminding people that, OpenStack is not just a collection of software and components, but it is also an open source community. And today is the day when I get to turn this sentence upside down and remind all of you that this is not just an open source community, but it is also an open source cloud platform. And then you may ask, what is cloud exactly? So for today's episode, we have Ben Silverman with us, who will share his thoughts about cloud. And he also has a lot of experience with OpenStack, how to deploy it, how the architecture looks like, and just really what it is all about, and how you can build a cloud platform out of all the services that OpenStack contains as a big box of Legos or as a big package. So he will help you understand all that. Before I give him the word, I will just again remind you to put your questions and comments in the chat. And I'm also turning to those of you in the audience who might already have experience with OpenStack to also please help us answer questions in the chat and make the chat even more lively for this episode, because we have a lot of amazing content to go through. So we would like to ensure that we have all the questions answered one way or the other. So with that, I'm turning to you, Ben, to please tell me, what is cloud and why do I need one? Or, well, as many as I can.
Thank you, Ildiko. And thank you everyone else for joining the session. It's been about 2 years since I've given a summit presentation or any sort of presentation on behalf of the Open Infrastructure Foundation. Doesn't mean I've been absent. I have just been kind of redirected. So I couldn't be more happy to come back and deliver a presentation for them. some of you may know me from YouTube. You're one of the, I don't know, 70 something thousand people who watch my videos on YouTube from the annals of the OpenInfra YouTube archive. But if you haven't, I'll let you know this session's been focused on those of you who aren't really clear on on OpenStack. What is it? How did we get there? How did it just sprout up in the desert? Or how anyone even arrived at OpenStack, where it came from, or how it works. There's really no prerequisites for this session other than some basic IT knowledge and the desire to learn. So this has always been my least favorite slide. I don't like talking about myself, so I'll make this short and sweet. I started my OpenStack journey way back in 2013 as I was wrapping up a data center migration project for American Express. I was looking for my next big assignment, and one of our senior executives asked me if I'd like to help him architect an OpenStack cloud. And he said it was going to be the next target platform for all the company's applications. Well, of course, if a senior executive comes up to you, I said yes, and I walked away. It took about 10 steps, and then I wondered, what is OpenStack? What did I just agree to? No problem, I thought. I'll just Google it, and I'll watch some YouTube videos, and I'll have the thing up at the end of the week. Not a problem. So off I went, I thought, here's, type it into Google, and I typed in Google, and it came up with some very strange results. I thought, well, maybe it's just the way I'm asking the question. So I went over to YouTube, and I saw the lack of instructional videos there. There were a lot of videos. So I started asking myself things like, where do I even get OpenStack? Do I go down to Staples and get a CD with OpenStack on it? Because that's what I thought I did. And I figured I'd learn from YouTube, what OpenStack was, how to install it from the CD, that I get from Staples, and then how to customize it for the financial industry requirements. At the time, as I was working for American Express, they had all sorts of policies and procedures and security requirements, but everybody had guidance on that, right? So there had to be guidance out there on OpenStack. Well, that wasn't very easy. I went into YouTube, and I remember seeing a lot of videos of people saying, especially the videos from Rackspace saying, hey, we've decided to join with NASA's Nebula project, and we're creating this new platform called OpenStack, and it's going to have these following components. And I thought, what do you mean you're creating it? You've got it. It's already created, right? It's on CD, down at Staples. And I spent the next couple months watching every YouTube video that was out there that mentioned OpenStack, that even talked about OpenStack. And I realized that I wasn't very much further down the line after a couple months. If you're done reading, these words about me, let me show you a picture of what I looked like after I was reading, watching all those videos. Right there. That's what I contracted. That's what the doctor said I had. OpenStack overload syndrome. That's right. I was diagnosed with the OpenStack overload syndrome. It was horrible. My eyes were stuck like this for weeks. I watched every video on YouTube about OpenStack, and I learned, lots of things about how people were excited, to be involved with OpenStack. Lots of discussions on how it would be created, gap analysis, how it would theoretically be set up, and lots of technical information, but very little on how to install it. So guess what I didn't learn? I didn't learn how to install it, where to get it, or which Staples had the CD. Luckily, when my eyes returned to normal, my company decided that they'd send me and a team to go to the next OpenStack summit. During that summit, I attended a lot of sessions, most of which I didn't understand, nor did they help me a whole lot. But what they did do is put me in touch with a lot of people who were in the same boat as I was. and they may have been in the boat a year before or 2 years before, when OpenStack first started in 2010. And they helped me. They helped me a lot. They helped me. They point me to some resources. They pointed me to some installers that were being created by hand. And I even met some vendors that were creating installers for OpenStack at the time and helped us move that project forward. But it was at that moment, it was at that summit that I vowed to never let anyone else suffer from OpenStack overload syndrome. And once I learned OpenStack, I began doing these beginner sessions about the why, where, and how of OpenStack. So today's agenda is going to be basically really is, what is cloud? We have to start from the beginning. How did OpenStack even get here? Without some other things happening, OpenStack wouldn't even exist. Then we'll talk about what is OpenStack. Without definition, it just sounds like two words that they threw together. How does it work? How to get involved? And then we'll have a little session on Q&A. What is cloud? So in order to start our journey, we need to understand why cloud computing is even a thing today. Let's go back to something like the early 2000s. Yes, I realize this is probably before some of you were even born, or maybe you were just a baby, but I was working in a data center where we simply had the job of racking, stacking, and imaging servers with the latest OSs and helping the applications teams load LAMP stacks. As Web 2.0 kicked in, the developers took more expanded role in the middleware, and as dynamic web applications started to become available. If you're old enough, you might be able to remember when web applications started to actually do something with in-browser applications or interactions with social media. Think WordPress, Facebook, Twitter, and blog sites. What powered these applications was simply an infrastructure with an arbitrary vertical scaling algorithm of hardware each time a triggered event happened, like the load on a server hit 70%. This would trigger a series of manual tasks and workflows, and that's what would kick off for more capacity. This is great for system administrators. It kept us in jobs, middleware engineers, data center folk, but really bad for efficiency and scaling. So what was so bad, you asked? Well, these servers were ordered by the dozens, and they were placed in data centers and racked and stacked and powered on, just waiting to be loaded with images and software and middleware. When they reached a certain trigger capacity, new servers were ordered, and later they arrived, and the cycle repeats itself. It was about a 55-day cycle at the time. Today, could you even imagine if an infrastructure team would tell a development team they have to wait 55 days for new space, new server, when they came up with an idea? I can't even imagine. I don't even know what would happen. It'd be chaos. There would be cats, holding hands with dogs. It would be insane. So, when we think about this scaling and this efficiency, you also have to think about what happens at Christmas, right? When orders push the servers at these data centers to 99% capacity on Black Friday, right? They were sitting at 40%, and then in one day, they all go to 99%. There's not 55 days between Black Friday and Christmas. So how would you scale up? Well, the answer is you would have to scale up way before. So when those dozens of servers might have become hundreds of servers, and then after the Christmas holiday, you couldn't ship them back to Dell or HP, couldn't put them on eBay to sell them and just temporarily recoup some of your money. Those servers held on, and they became expansion hosts. And those expansion hosts, they would get old. Time is money, and new technology comes out. So in 6 months, when they were adopted and put in, the processors were old, sockets were old, everything was old. So there had to be a better way. So in 2006, Amazon had run into these same scaling and efficiency problems. They realized some of its hardware was mostly idle off peak. We're talking 10, 20% off peak. While their other systems went overloaded at peak times. but they had to make sure that availability was there, like everyone else, for their retail customers, for their book buyers. Yes, that was back when Amazon just sold books. With that in mind, Amazon set out to create a way to give development teams and infrastructure admins a way to deploy infrastructure in a self-service way. This is how AWS was started. It allowed Amazon to abstract all those wasted resources, those idle resources that are happening in off times, yet scale up on demand when they needed to. It allowed them later to resell their own resources during off-peak, which increased efficiency exponentially, and then the rest is history. Additionally, another company had a different idea on, and again, it wasn't called cloud at the time, it was just ideas on how to become more efficient and scale efficiently. A company called Salesforce, maybe you've heard of them, I think they're still around, had a different idea on how to make themselves more efficient. They decided to enable their software to be run via web browser and have customers use their infrastructure to operate it. By bringing customers to them, they controlled the scale, were able to fully utilize the infrastructure, and didn't have to deal with customer software upgrades or any of the on-premise legacy problems of customers running software applications, because they managed and ran it themselves. Of course, it's hard to keep a good thing a secret. And these two companies inspired a lot of new ideas about what was to become cloud computing. So we talked about the lengthy acquisition cycle of new resources for app and dev teams in the early Web 2.0 days. Days and days of approval workflows, hardware provisioning, cabling, network connection requests. And I talked about the 55-day provisioning cycle, and I saw that in my experience. 55 days was not uncommon. I didn't even mention what happens if they ran out of blue cables or green cables or red cables or any of the cables that they used to connect into the racks that had to be of a certain type or color. If those were back ordered, or if they had some sort of problem with those, or even if there was a logistical issue, it could push that provisioning period to 100 days. I mean, we're seeing today with customers, with certain vendors, things coming out of China, even in the modern day where we have, the cloud concept. We're seeing delays for memory. We're seeing delays for chassis. We're seeing all sorts of delays. And when we have to deliver bad news about a 10-day delay, they're up in arms. But it wasn't that many years ago that a 10-day delay was really nothing. It was absorbed into the 55-day, 75-day cycle of getting hardware. Today, 10-day delay is almost unthinkable. It's almost an emergency. So we can see the difference between the two different times. So we talked about this lengthy acquisition cycle during the getting resources for the app dev teams in Web 2.0. Days and days of approval workflows, and we experienced those as well. We would have to, back then we were show my age again. We were using Lotus Notes, and we had Notes forms, and we would have to submit them to leadership, and they'd have to be signed off on. And of course, Lotus Notes wasn't the greatest software in the world to begin with. Sorry guys, but it wasn't. But in order to go from manager to manager to manager to manager to sign off on each piece of the infrastructure, we had these huge approval workflows that would take forever. So we had the hardware provisioning, the cabling, the network connection requests. There was never enough ports, or your request was had an SLA of 15 days, and it seemed like they would always use 15 days. So, and again, these are common things within companies, but it was all to just get infrastructure for whatever reason. Let's say for this discussion, it's to get space to develop a new app, maybe something cutting edge, something that's fresh, some blockchain or some IoT app that is really hot on something that's going on, in the community or in IT. We're talking 55, 60 days. What if your idea was so fresh that if in those 55, 60 days, you lose your competitive advantage, um, waiting for infrastructure to be delivered to you? Um, if you don't get to the market first with an idea anymore, you're last. And I don't be Ricky Bobby, right? If you're not first, you're last. But in a lot of these cases, if you're not first, you're last. So, during this time, people were saying there's got to be a better way. There's got to be a better way. And there were tools that were coming out, for other vendors of other software to allow them to do self-service, but it was never cloud enabled. It was never API enabled. It was never programmatic. It was never infrastructure as code. It was always just ways to shave off workflows or do workflows a little faster. I think when we had enabled some things like that, it took us from 55 days to 51 days, which I consider negligible. So it's not what we use to speed up the process. It's what's the outcome of the goal, not the output. The goal is to increase efficiency and to deliver infrastructure so that we can be first to market. That's the outcome, not the output. How many VMs you can create in an hour, or how many VMs you can create end to end with the fewest amount of workflows. It is the output goal. So in this slide, you can see here the value of cloud computing is in the outcomes it enables, not unlike the outcome of an elliptical trainer. The value is in the outcome, building cardiovascular health or losing weight, versus how many times your legs move back and forth, right? We don't get on an elliptical to see how many times our legs can move back and forth, right? We don't get on there to make ourselves better at ellipticals. Maybe some of you do. I don't know. I don't. I don't get on there to become better at elliptical using, right? That's the output, right? My arms are moving back and forth. But what is the outcome that I'm looking for? Greater cardiovascular health, weight loss, muscle toning. And the same thing we look at with cloud computing. We see the definition here that it has to be scalable, have shared services, service-based, reachable via the internet. These are all NIST definitions. Great. Those each have output goals, but it's the outcomes that cloud would need to achieve in order to be successful. So we talked about the elliptical trainer, but now imagine elliptical with an arm and a leg-based API. So instead of spending all that time getting dressed, going to the gym, waiting in line for equipment, waiting for the sweaty guy to get off and then wipe it down for you and then spray it with the chemicals that don't really kill anything, you could just plug your body into the API, the elliptical API, dial up 1,000 repetitions, and you just get skinnier and stronger just standing there, right? Because you have programmatic access to the elliptical. You don't have to flail your arms and legs around. You just plug in to the API or set of APIs, and instantly you're smaller. Fortunately, that doesn't exist. And if any of you have any ideas for that, or feel free to write to me. I would love to get in on that project. But this is sort of like the magic that cloud brings to programmable infrastructure. Oops. So in 2020, moving forward, IDG reported that 81% of companies they surveyed planned on increasing cloud adoption, and 19% of companies they surveyed were planning on completing a total cloud transformation in which they were completely moving to cloud infrastructure for their company. OpenStack is part of that story. But in order to see where they fit, we have to talk about the two different types of clouds. So we went from a hardware-based and workflow-based infrastructure provisioning process to a programmatic process where it's driven by APIs, or driven by a web interface to create infrastructure. But that's not the whole story. When we talk about cloud, it's not just like we talk about ice cream, right? We say, go get me some ice cream. What's the first thing you ask? Well, what's the flavor? What flavor do you want? Now, of course, it's, do you want gelato? Do you want, yogurt? There's a lot more dynamic to it. But we ask the flavors. Well, cloud is not just cloud. Cloud has different modalities and different types. What we talk about here with the types is first private cloud. And private cloud is where OpenStack comes in to the picture. It's dedicated many times. It's dedicated to a single user. Can be hosted can be a hosted private cloud in a customer or vendor's data center, or as a remotely managed cloud, but it's private to the enterprise. It's private to the company. It could be hosted but private. Not to say that again that it can't be one of the other modes, but this is where it primarily lives. Public cloud is a shared resource with a pay-as-you-go metered billing mode, usually. So these are your AWSs, your Azures, your GCPs, your Rackspace. Now that I said that OpenStack is mainly a private cloud, or started off as mainly a private cloud platform, Rackspace has turned it into a public cloud platform. So they use OpenStack underneath their public cloud platform. That being said, that brings them into these other two modalities. Multi-cloud, which is using multiple clouds like AWS and Azure, or OpenStack and AWS, or OpenStack and Azure, to spread an application across multiple clouds. So there's no cross-pollination or cross-API traffic between the two clouds, but the apps live in those clouds, and for reasons of follow the sun or HA or disaster recovery, the app is on multiple clouds, and that's multi-cloud. Hybrid cloud, and again, you may hear different definitions of this as you go through. I used to have in my presentations definitions from all the different vendors, and you could see really how disparate they were. But these are kind of the generally understood definitions. Hybrid cloud is a mix of private cloud and public cloud, or it could be two public clouds mixed together. However, the workloads are spread across the different clouds. So you may have your web and app tier on one cloud and your database tier on another cloud. So you may have your web and app in Amazon, but it reaches back to your private cloud, let's say OpenStack cloud, on premise to get its source of record, to get its data. So those are the four main types of modalities of cloud. Within those clouds, there are service models. So these are the service models are what you hear about when you talk about provisioning something, or the way it operates. The five current modalities that everyone's usually talking about are infrastructure as a service, container as a service, platform as a service, function platform or function as a service, and then software as a service. And if you look at the slide that I just put up, you'll see that there is a private portion of it, private cloud portion at the very top, that shows examples of private cloud parts of these different service models. For example, IaaS, for short, for infrastructure as a service. Examples of that would be OpenStack, vSphere, Azure Stack. Can't think of any others there. And then the public version of that would be in the box with the dotted line below that's listed hosted. And that would be AWS EC2, Google Compute, Azure VMs, things like that. Same thing with the container platform as a service. You have Kubernetes, you have OpenStack Zune, You have OpenStack Magnum as a management service. And then in the public cloud, you have GKE, ECS, and ACS. Again, if we look down through all of these, you'll see examples of all of them. You can even have a SaaS platform, private SaaS platform, where it's hosted on your private cloud with OpenStack, and a BYO is you bring your own. So there's really, I mean, there's an unlimited amount of SaaS offerings that are out there, but they're usually custom to the particular cloud. But you can see that the OpenStack logo is there and has a big bracket across all of them. OpenStack services all 5 of those, whereas some of your other options here come from multiple different vendors, but OpenStack can handle all of these on its own or with third-party vendors. So OpenStack really is a total solution for not only modalities, but for the models here as a service model. It is a complete solution. If you were confused by the as a service models, I like to use this slide. I think it's funny, it's entertaining, but it's pizza as a service, and it really illustrates what we mean by as a service. So, for example, we would start it at on-premise, right? On-premise is akin to the old data center model, where you have configurations, functions, scaling, runtime, OS, virtualization, and hardware. Here we have it: conversation, friends, beer, pizza, fire, oven, and then your electric and gas. As all the things that you would need for your application stack. All the way down into the hardware. So, for example, like on-premise would be, like a homemade pizza made from scratch. You do everything yourself. No change, no changes so far, right? This is the old way we did everything. We bought the machines, we plugged them in, we powered them up, we cabled them, we put the OS on them, we put the middleware stack on them, we loaded our applications on them. We did everything ourselves. There was no provider that helped us out with that, whether it was a private cloud provider or whether it was a public cloud. And then we get to infrastructure as a service. Well, things start to change, right? So now we're given infrastructure. So it's akin to like you share your kitchen with other people. Utilities and oven are provided, but you make and cook the pizza yourself. Kind of like EC2, kind of Amazon's EC2, or even OpenStack VMs. So the kitchen would be akin to your infrastructure, your virtualization, your hardware, your infrastructure. Then you get to containers as a service. You bring the pizzas, but someone else uses the facilities and cooks the pizza for you. So you bring your app, you bring your maybe even bring your OS, and then you hand it to somebody and you say, hey, here's all the ingredients. Go ahead and make it for me. And some chef sets it all up and gives you your containers or your pizza. Platform as a service, you order the pizza for takeout. The pizzeria makes and cooks the pizza using their facilities, and then you just come pick it up. And again, all you have to bring is the conversation, the friends, and the beer, right? So the pizza's already made for you, but you still have some things that you have to do. And again, which would be application, different functions, scaling. These are all things that you still need to worry about in platform as a service. Function as a service, again, your responsibilities decrease and the provider's responsibilities increase. So function as a service, you go to a pizzeria with some friends, you order and then eat the pizza made by the restaurant. You order drinks from the bar and they're made for you. And then you have those drinks. So now you're not supplying the beer. It's a craft beer where you order mixed drinks and they make it for you. Now all you do is you have to bring friends and bring the conversation. That's it. And again, that would be akin to bringing your functions and whatever they're going to do, whatever the functions are going to do, or the configuration of the functions. And then software as a service, you go to someone's house for a party. They provide you with the pizza. They invite others to come talk, and hang out with you. And the only thing you have to do is talk. You just show up and talk. So with software as a service, you just go to the site, connect to it, run the software, and then when you're done, you log out and you're done. You don't have to clean up. You don't have to make pizzas. You don't have to serve drinks. You don't have to do anything. Everything is done for you. Just like the Salesforce, or if you think maybe even Gmail. Gmail is a good software as a service example. Right? You don't have a mail server. You don't have anything to worry about but just going and reading your mail. Maybe that helps you. Maybe that's confuses you even more.
Before we move forward, I would just jump in a little. I would like to say that I really love all this background. I have personally a much better understanding of why I need cloud and what kind of solutions are out there, and how those different terms are relating to each other and what they mean. I also want pizza now, so I need to go and look for a breakfast pizza option somewhere. I also love the really lively chat that we have on the different platforms. People are talking about deployment tools and options, hardware options, things like SmartNIC support in OpenStack, CI/CD solutions. And there was also a question about, where can you find answers to your questions. So I would just like to remind everyone that one of the best places to reach the community is the OpenStack Discuss mailing list that you can subscribe to. And if you have any questions that we did not answer today, then you can always reach out to the community and find them there. And now we are switching gears and looking into what OpenStack itself is, how its architecture looks like, and how it will deliver pizza to my front door. Back to you, Ben.
Thank you. So what is OpenStack then? Right. So we've talked about cloud. We talked about the different modes, the modalities. What is OpenStack? And really, just to be very simple, you may already know this because you're here on this call, but OpenStack is open source software for building clouds. It's programmable infrastructure that allows users to have one platform for virtual machines, containers, and bare metal. I'm going to say that again because that's very important, right? Because you're not going to get that anywhere else. For virtual machines, containers, and bare metal. It's software that's been written by tens of thousands of individuals from hundreds of companies. It's not a single product. It is a set of projects that make up foundational services like compute, networking, and storage, but also cover areas like telemetry, containers, security, and billing. OpenStack is not virtualization. It uses virtualization. OpenStack doesn't manipulate the underlying OS. It uses tools native to the OS to achieve that. OpenStack uses all these elements to build clouds from modular architecture that you choose, not someone chooses it for you. OpenStack builds clouds using APIs to abstract physical resources and combine them into useful programmable infrastructure. So OpenStack, free open source software. I'm not going to spend a lot of time on this slide. I would encourage you to go out to the openstack.org site and really look at these 4 open principles. But one of the things that makes it great, and I want to mention it, is the choice you have. It's open source. You can get involved. Open design. People can put in their own opinions. They can open development, and it's an open community that helps everyone, that they share knowledge, and they have open discussions about the future of the platform. And that is what makes it great. So based on the OpenStack user survey, it's been run since 2013. People have placed their feedback as to what is most important. Why do they use OpenStack? Right? We talked about operational efficiency of cloud, and now we're talking about OpenStack as part of that domain. 94% of users said cost was their first business driver. People do not like to be locked into vendor managed or vendor platforms. They they find that paying for enterprise features and then not getting exactly what they want, and then having to pay for more add-ons and add-ons and add-ons and add-ons, is just not operationally efficient. And that's what drove so many people and continues to drive people to OpenStack. To accelerate innovation. We talked about that being first. If you're not first, you're last in this market. If you can't get your infrastructure ready for your developers to develop and push out into production, you're not going to win. And again, avoid vendor lock-in. We don't want to be locked in. We don't want to be locked into someone else's idea of what a platform should be. And again, some of these, and I said it, and I'll say it again, and I'm not going to pick on one vendor, but certain vendors, you send them a request for enhancement, and I'll tell you where it goes. It goes right in the garbage. They don't even look at it. But with OpenStack, you can put in a feature request. You can design a feature, and it will be discussed, and you will be part of it, and others will be part of it. And if it's a good idea, and the community recognizes it, it will be implemented. So really, who uses OpenStack? I don't know. Maybe some of these companies. Actually, all of these companies. I mean, there's got to be a company on here you've heard of or seen before. 15 million cores. So the people who say that OpenStack is dead, although they've been saying OpenStack is dead since 2010. If OpenStack died as many times as they say it's died, then it holds a record for dying and coming back to life, because it just keeps growing. It keeps expanding. It keeps reaching out to new people. And again, this is proof positive. These logos themselves show that it's not going anywhere. So what really runs on it, right? So it's out there. People have it, right? Well, maybe it's just one sector. No, it's not. They've got lots of different sectors. Again, if you go to the OpenStack org site and go to the software section or the use cases, you'll see that there's tons of them out there. Not just telco, not just banking, not just big data. It's really, really diverse. We're 10 years in. It's hard to believe. I guess kind of technically we're 11 years in. They have some of these milestones here that just blow me away. As I said, I've been involved since 2012, 2013. And I've seen things happen with OpenStack that I never dreamed that would happen. It's still going strong. Still have milestones to reach. Who is OpenStack, right? What is OpenStack? OpenStack is people. People are teams. The Open Infrastructure Foundation helps people form teams to solve problems and create solutions, right? That's what they're there for. I look at this picture and I can recognize a ton of people in this picture. And it's amazing I can, because I've met a lot of people, with OpenStack, and this is just a small smattering of the people, and 111,000 people. It's mind-boggling of how many people have touched the code, have looked over the code, have found bugs, corrected bugs. It's really an amazing network. OpenStack releases. OpenStack releases have always been on time. Sometimes the times change, but when they say they're going to release it, they release it, and it's about every 6 months. Back in 2019 in October, it was Train, Usuri, Victoria, Wallaby, and the next one is going to be released in October, and that's Xena. I always laugh. I'm not going to do it today, but I always, when I do this live in a summit, I'll always challenge myself to go through every release, see how fast I can go through it. It's a little early today, so I'm not going to do it. But the names are interesting. They allow you to they're unique. You're not going to forget them. Although Newton, I always call null, because that's what I voted for. And I really thought that was going to win until I had some discussions with some programmers, and they said, you realize what would happen if we named the release null? And, there were lookups against the release and it was coming up with null. And I said, yeah, you're probably right. So I'm glad that one didn't win. But anyway, that's the release cadence. You don't have to upgrade every time. You upgrade basically when you feel that the feature set is appropriate for you to upgrade, but it's backwards compatible to at least n-2. So they release -2. And then the APIs are backwards compatible. So you're not going to, for the most part, they're backwards compatible. There are some things that get deprecated in newer releases, but they're well documented. All right, so we made it to the important part. How does it work? Right, so we've got this cloud operating system or this cloud platform. So how does it work? Remember when I talked about before, it's a common misunderstanding that OpenStack is a single product. OpenStack is a group of open source projects, and which projects you need will depend on how you want to use OpenStack. While there's a large list of projects you can plug into your OpenStack cloud, not all of them are necessary, for all use cases. And all projects have reached maturity with the service that they provide. These projects are still included under the OpenStack umbrella, all of the ones that have reached maturity, and because they work towards the OpenStack mission. And some users want, some users want access to the projects that used to be what they call an incubation, or projects that may have lost support. Those are all still there. They're there to be picked up again, to have a team work on them, but there are projects for almost everything you could possibly think of. When you explore OpenStack projects, you'll find several tags that'll help you understand where this project is and what projects are right for you. On the foundation site, openstack.org, you'll find a list of sample configurations. These sample configurations are combinations of services for different use cases, kind of informed by the case studies of real-world users. In the sample configurations, I encourage you to look at a sample called Compute Starter Kit. The services they built for this use case are the foundation, supported by the optional services around them, and they will help you start a cloud, the cloud that you need, not a cloud that has everything, right? You don't want to bolt on a bunch of stuff that you don't need. So you could look at that, look at the Compute Starter services, there's the Compute Starter Kit, and you will see that it includes Glance, Nova, Keystone, and Neutron. We'll talk about those in a little bit, but not all the use cases require all 4 services, but you need the services relevant to your use case, and that is a good starting point. That will, for 98% of the use cases that we see, that is a good starting point. So remember that when you go out to the site. This is the OpenStack landscape. These are the projects that are active right now. And I won't harp on this. I could spend all day going through each one of these projects and talking about what they are and what they do. But this diagram is available for you. There's explanations on openstack.org that tell you about each one of these projects. We'll go over to the main ones today, but just know that there's a whole world out there that does all sorts of things, from billing, business logic, to performance testing and benchmarking. These are all things that you can plug into your OpenStack cloud. So, as I said, I'm going to go through the most common services, or the most common projects, and this is the list of them that we'll be going through today. I'm going to say the names a bunch of times, so that if you're not familiar with the actual names, because that was one of the hardest things for me, right? Somebody said, "Hey, when Nova reaches out to Glance, and what Nova, who Glance? What are you talking about? Like, can you just say it and what it is? An image service, compute? No. We use the names, right? The cutesy names." And I thought that's pretty dumb. But then once you use them for a while, you start to kind of get a feel for it, right? How they interact, and then it starts to make more sense. But I'm going to keep saying the names so that you're more familiar with them. We'll go over them right here. The dashboard, the GUI that you interact with is Horizon. It drives all the API requests into these other services. The identity service is Keystone. Compute is Nova. Block storage is Cinder. Networking is Neutron. Image service is Glance, and the object storage is Swift. So now if that's the first time you've heard them, that's the first time I've said them, we'll move on. So Nova Compute. I don't really have a good mnemonic way to remember Nova Compute. It used to be called Nebula. That's really irrelevant today, but Nova in Spanish is no go. That's why the Chevy Nova never sold many cars in the Latino world, because would you buy a car that said no go? They actually renamed it to the Diablo, which happens to be a OpenStack release. I don't know where I'm going with this, but this is really going badly. So Nova, you're just gonna have to remember Nova is compute. I remember there was a public broadcasting show called Nova, and it was like a big deal for me. So I always thought, well, Nova's a big deal. Nova's compute. It actually implements services and associated libraries to provide on-demand self-service access to the compute resources, including bare metal, virtual machines, and containers. It also provides a way to provision EC2 resources. Utilizes the REST API and is driven by messaging, and uses the placement service as well. There we go. That's the next one. Cinder. Okay, here's one that I can actually give you a mnemonic device for, right? Cinder. Think cinder block. I'm sorry if English isn't your first language. That may not translate well for you, but cinder blocks are large concrete blocks that a lot of the buildings are made of. And I always thought, storage, cinder block, storage facility made of cinder blocks, cinder block. So the OpenStack block storage service, block storage, cinder block, provides persistent block storage for compute instances. So it provides persistent block storage. It also can provide you secondary storage, much like Amazon's EBS or Azure Storage Disk. It can be used to create volume snapshots for bootable volumes that can be detached and reattached to new instances, uses a backup volume. A lot of the backup software that's third party actually uses Cinder. Neutron. Okay, here's another one. So Jimmy Neutron. Jimmy Neutron was a cartoon character with when I was a young kid. Used to fly around in a spaceship and go bouncing around all over. So it reminded me of network packets, or think of neutrinos, something like that. It's the network component. It provides networking capability for OpenStack. It helps ensure the components can talk to each other, and it's software-defined networking for OpenStack. So before Neutron, there was Quantum and Nova networks. There are ways to implement kind of a flat network, Nova network, but anything you read with that is kind of it's not really relevant anymore. So just think Neutron, neutrinos bouncing around network. And it just basically standardizes and abstracts the networking from the physical layer and allows you to concentrate on building programmable infrastructure. Glance, picture in your mind, kind of, I glanced over there at that. There's a picture in my mind. Image, picture, image service. Glance holds the images for your compute. So again, REST enabled. It's used for discovering and registering and retrieving VMs. It stores images and metadata about your images, your AMIs, if you will, if you're in AWS, and it supports so many different formats including AMI, QCOW2, VMware, VMDK, RAW, you name it. Swift. Swift is the object storage. It's not very swift. I think that's what I come to learn about it over time. It's an eventual consistency, so it's not instant consistency. It kind of takes its time to get through, especially if you have Swift spread across large distances. Swift nodes, it kind of moves slowly. So it's I don't know how else to help you remember that. Again, this is one of the early services, and I don't know why they call it Swift. If anybody knows that, that would be great to know. But it's a highly available, distributed, even eventually consistent object blob store. Think of it's fully S3 compatible. So if you want to think of object storage, this is what it is. It's object storage. It's everybody, I think a lot of people are very familiar with object storage nowadays. So it's the same technology that Dropbox used for many years, for many enterprise storage clouds, the Fortune 500. So again, object storage is Swift. Keystone, identity, right? Keystone, key, lock, safe, keystone, identity. Key, lock, safe, keystone, and it's I would say one of the most important, but if not the most important, project in the OpenStack architecture. It processes API requests, provides identity tokens, allows you to log in, allows the services to talk to one another in a secure manner, and provides a service registry that registers all the services that are available in the cloud. Okay, so for you AWS users out there that are looking into OpenStack, here is a slide for you. I'm not going to go over it, but it's not an all-inclusive list. This list could probably, the Rosetta Stone for AWS could go on for pages and pages and pages. There's not 100% feature parity here, but if you're trying to memorize it based on what you know about AWS, it'll be a good help. So here's the OpenStack simple conceptual architecture. Take a good look. This is what it looked like to me when I first started, but really this is a Tokyo subway map. But this is what it looked like when they started giving me diagrams when I first started OpenStack that looked just like this. I don't bring them up anymore, the real ones anymore, because they're just more confusing than anything else. But here, how is that one better? So this is the simple conceptual architecture, and really this is not complete, but it really does a great job of saying this provides for that, this provides for that, this connects to this, and does what this is what this does in relation to that. It's very, very useful. And we'll go into this a little bit more detail in a second. This is the most important slide. If you understand this, then you will understand how OpenStack works. At the very top, you see your stateless services, your REST API. The request comes in the top, and then it goes down all the way to the bottom. And along the way, it sends messages out to the message queue, RabbitMQ, for CRUD operations and have information so that the next service or the next part of the service can pick it up. And for example, like if you were talking sender, you would have a request for a volume. It would come in, it would put it out on the message queue. The scheduler placement service would pick it up, make a placement decision on what storage that you have available, whether it's storage frame or Ceph or whatever it is. Say yes, there's space available. We put it back onto the message queue. Then it would go down into the service functionality. It would be pulled off the message queue, and then at the same time, it's being recorded in the stateful database, the MariaDB, and placement decisions are being recorded in there, and there's other metadata that's recorded in the database. And through the service function, then into the driver for whatever storage that you have, and then onto the provider. So if you have some sort of net app or something, it'll talk right to the provider. But all of this is taken care of for you by OpenStack. You don't actually talk to the providers. OpenStack will do that for you with this service by abstracting all of the things at the bottom, so you can just talk to the APIs at the top. And an example of this would be a complete VM creation process, right? Users log into the Horizon dashboard and then initiate a VM create. The identity down here authorizes, says okay to the dashboard. Then the Nova API initiates provisioning and saves the state. Remember what I said, it saves the state to the DB as it's going along. The Nova placement service finds the appropriate host of where it's supposed to go. Neutron then gets involved and configures networking. Then Cinder gets involved and provides the block storage for the VM. The image's location in Glance is looked up through Glance. The image is retrieved out of the object store, which is hosted by Swift. And then all this information comes together at the end and is rendered by the hypervisor, whatever hypervisor you're using. Whether it's KVM or Zen or EC2, whatever it is, whatever the hypervisor you have, because you have choices with hypervisor as well. And now, number 10, the VM is accessible by the users. And that's how OpenStack works. Everything works just like this. REST API goes through, puts things on the message bus, records them in a database, moves through the different steps, and then does the abstraction and creates the resources for you. It's not magic. If you understand this part of it, even in a general sense, you've got it down. And I'm going to turn it back over to Ildiko. I know we're running really late.
Well, just a tad bit late, so I will be quick, but would like to thank you for this amazing overview. And now, for me, things are turning back to normal, where I can remind people again that OpenStack is not just software, but it's also a community. So you could already see that in the chat of the different platforms where we had a really lively chat with questions coming in. People, some from the community who I know, answered them, and there was a really lively discussion. I believe we don't even have any question that did not get answered at all. So this is what really the community is all about, and you all who are watching this episode can be part of it. And you may ask, how? So there are a couple of resources, like on the next slide. We do have an upstream training. It's called Upstream Institute, and it is actually teaching you how to become part of the community. It talks about OpenStack as a community, how it works, how it's structured, what kind of processes we have, and how you can participate. We have materials. You can see the links on the slide. So we do have a contributor guide that you can look up independently from the training, and it will guide you through all these processes and tools that the community is using. And we also have the training materials that will give you a little bit of guidance in terms of maybe what order you want to go through the contributor guide if you don't want to read it as a book. We are having some online versions of the training due to current circumstances. So look out on the website. We will have the new dates up once the next occasion is all settled down. We will probably have one upcoming this year around mid-November. And once you kind of have all your courage, then you can go on the next slide, a couple more links in terms of, I already mentioned the OpenStack Discuss mailing list. That is a really good place to get in touch with the community. Like it is a good tool for asynchronous communication because the community is spread all around the globe. So if you're jumping on IRC, maybe the person who you're looking for is still sleeping. Because it's night where they are, but you can always drop your question or idea to the OpenStack Discuss mailing list. I mentioned our foundation at the beginning of this presentation, so you can also join the foundation. It's probably a good time to also say thank you to all of our members because without their support, we could not bring OpenInfra live to you. And if you would like to join them and support the foundation, then you can do that at openinfra.dev/join. And user survey for all of you who are either considering to run OpenStack or maybe you deployed it already and it's running in production. We would love to learn about your plans and actions. So please fill out the user survey to help us understand how OpenStack is used all around the globe, what kind of use cases you're using it for, because from Ben's presentation, you can see like how cloud is applicable to our everyday lives and in what ways you can use the software that turns your bare metal servers into a lively, flexible, manageable, programmable infrastructure. And there are so many ways to use it. And I believe there was a question about the future of OpenStack. So the user survey was one way to bring you the answer just based on learning how it is used around the globe. And just in a bit, I will tell you what we are coming to you with next week, which also highlights some amazing use cases. So again, thank you, Ben, for this amazing presentation. And I would also like to thank everyone in our audience because the chat was really, really lively today. That was amazing to see. And now, just because we are over time, let me remind people what an amazing episode we have for you for next week. It is actually part of a mini-series within the series. It's called a Large Scale OpenStack that is brought to you by the Large Scale SIG, or Special Interest Group, within the OpenStack community. And they are always talking about the ways of how OpenStack is run on a large scale all around the globe, the challenges and solutions of that large scale infrastructure, how you deploy and manage that. And with all the use cases, next week's one will be super exciting because we will be talking about supercomputers. So next week we will have Stig Telfer from Stack HPC, Sadaf Alam from Swiss National Supercomputer Center, Happy Sidol from Center for High Performance Computing in South Africa, Steve Quinnett from Monash E-Research Center, and Jonathan Mills from NASA Goddard Space Flight Center. And you can see that I have a little space shuttle in my ears. So it will be a really exciting episode. Now that you know the basics of how OpenStack works, you can go deploy and explore the software. And next week, we will tell you how you can build a supercomputer in your garage out of it. And if you got inspired by this and you have a story to share, please don't forget to submit your proposal to ideas.openinfra.dev and mark your calendars for next Thursday at 1400 UTC and be back here for the OpenStack Powering Supercomputers episode. And with that, thank you all for being here with us today, and I hope that you will have a lovely rest of your day.
Thank you, everyone.